Hello everyone, welcome to the next session of the chapter Carbon and its Compound. In today's session, we are going to understand why carbon forms covalent bonds, what are covalent bonds and what are the various types of the covalent bonds with their examples. So let's begin the session. Now, first of all, we will try to understand that why carbon forms covalent bond. Carbon forms covalent bond because of the following reasons. We'll explain them one by one. From our previous knowledge, we know that the atomic number of the carbon is 6. So its electronic configuration is 2, 4. That is, in the first shell, it is having 2 electrons. In the second shell, or which is also its last shell, it is having 4 electrons in it. Now, for an atom to become stable, it should have 8 electrons in it. Now, carbon is halfway filled. It needs 4 more to achieve 8 electron in its last shell. Now, the first option is obviously to gain 4 electrons. Okay, but gaining of 4 electrons makes it unstable. Why? Let us see. The electronic configuration of the carbon, whose atomic number is 6, is 2, 4. After gain of 4 electrons, it will become 2, 8, just like neon configuration it is. Okay, if we draw the structure, this is nucleus, first shell with 2 electrons, this one, and second shell with the 4 electrons, 1, 2, 3, 4. Now to this carbon, if you want to add 4 more electrons, what will happen? These electrons 1, 2, 3, 4, 5, 6, they are also negatively charged. These are also electrons. So when you are adding negative charge to a negative charge, there will always be a repulsion, because like charges repel. So this repulsion will make this atom unstable. So carbon never gains electron. Now the other option is to lose the 4 electrons. What will happen after losing? If carbon will lose these 4 electrons, it will have only first shell with 2 electrons in it. Here carbon 6 atomic number 2, 4. If it will lose these 4 electrons, so it will have only K shell, which is the first shell with 2 electrons. That is, it is also a stable condition, because in the first shell 2 electrons should be there for an atom to be stable. Okay, now let us see what happens in this case. This is nucleus, first shell with the 2 electrons and second shell with the 4 electrons. Now if you want to remove 4 electrons from the last shell, you need high amount of energy. Okay, we are going to need high amount of energy, and this high amount of energy, or due to this demand of high amount of energy to take out these 4 valence electrons from the carbon last shell, it will again make the atom unstable. So gaining or losing, it's not an option with the carbon. So carbon always forms bond by sharing, and such kind of bonds are called as covalent bonds. Now before explaining covalent bond, I'll give you a brief about the structure of the carbon. Carbon forms 4 covalent bonds. Why we are using 4? Because see, this is carbon, these are its 4 valence electrons. So it will form 4 bonds, 1, 2, 3, 4. The 4 valencies of the carbon are shown with the single line. This is one line, this is second line, this is third line, this is fourth line, this is carbon in the center. Okay, so carbon generally shows a regular tetrahedron structure to us, and the bond angle between any two is always 109.5 degrees. So now we'll go to our next topic, which is that what are the covalent bonds. Okay, So covalent bonds, we know that they are formed by the sharing of electrons. So a chemical bond which is formed by two atoms, any two atoms, by mutual sharing of valence electrons, so that each atom acquires stable electronic configuration of the nearest noble gas is called as a covalent bond, and the number of electrons contributed by each atom for sharing is become its covalency. Such compounds are called as covalent compounds. Now the properties of the covalent compounds: they are poor conductor of electricity, they have low melting and boiling point. Why so? See, any of the covalent compound, if it is a covalent compound, then it means what? They are formed by covalent bonds. Okay, and if it is a covalent bond, it means there is no presence of ions. That is, there is no positive or negative charge. So if there is no charge, there is no presence of the charge, then obviously it is going to be a poor conductor of electricity. Okay, if there is no positive or the negative charge, then you can understand that the bonds are not very strong. The bonds are not strong. Why? Because you know that opposite charges always attract. So the force of attraction is weak because there is no charge. Like this is not having any charge, this is not having any charge. There is no charge, okay, to make the force of attraction strong. So there is no charge. These bonds are formed by the sharing. So there is no involvement of the positive or the negative charge. So the forces of attraction is also weak. Force of attraction is weak, and that is why they have low melting and boiling point. That is, they quickly reach to their melting or the boiling points. Okay, another property is this, that they dissolve in organic solvents. They dissolve in organic solvents. Organic solvents are generally alcohol, you can say. Okay, so in them they get dissolved. Now let us try to understand the various types of the covalent bonds. So there are various types of the covalent bonds depending upon basically the number of electrons shared. So the types of the covalent bonds are three. There are single covalent bond compounds, there are double bond covalent compounds, and there are triple bond covalent compounds. What is the difference between them? In the single type of covalent bonds, the one pair, you can say one pair of electron is shared between atoms. Okay, in the double there is a sharing of two pair of electron. In triple there is a sharing of three pair of electron between the atoms. So this is the difference. It will become more clear to you with the help of the examples. Now first is single covalent bond compounds. Now here I have written H2 molecule. So it is telling us there are two H. So this is one hydrogen atom, this is another hydrogen atom. Valency of one hydrogen is 1, another is obviously 1. Hydrogen valency is 1. So we are showing them with the dots. Now hydrogen atomic number is 1 so its electronic configuration is 1 and it is in the K shell. So K shell is the first shell. It can have maximum of 2 electrons. Okay, out of 2, 1 is there. So what is the need of the hydrogen? To gain 1 more. So what it will do? This hydrogen will take this hydrogen 1 valence electron. Now this hydrogen atom is now having 2 electrons in its first shell. So it is happy. Now this another hydrogen atom which is also having 1 valence electron here, and it also needs 1 more. So what it will do? It will take the other hydrogen atom 1 valence electron. So in this way both of them shares 1 pair of electron, 1 pair of electron. So this is a single covalent bond. Okay, it can also be written as H dash H. This H is showing the single covalent bond among the among the hydrogen atoms. Now similarly, if we go to the chlorine, there are 2 chlorine atoms, Cl and Cl. Now the valency of the chlorine is 7. Its atomic number is 17. So its electronic configuration will be 2, 8, 7. So in the last shell, you know that it needs 1 more electron according to the octet rule to become stable. So there are 7 valence electrons. So you will have to draw its valency around it. 1, 2, 3, 4, 5, 6, 7. You can change the symbol. Here I am making a cross so that you can differentiate easily from the H2. 1, 2, 3, 4, 5, 6, 7. 7 valence electron of this Cl, 7 valence electron of this Cl. Now, chlorine needs 1 more to attain the stable electronic configuration. So, this chlorine atom will take 1 electron, or it will share this electron with the neighboring chlorine atom. Now, similarly for this chlorine atom, it will take 1 electron from its neighboring chlorine atom. So in this way again there is a sharing of 1 pair of electron. Okay, so this is also an example of single covalent bond compound. Now if you see NH3, which is also called as ammonia, in this case it is having nitrogen and hydrogen atoms. Nitrogen atomic number is 7, so it is 2, 5. Its electronic configuration, its atomic number is 1, so its electronic configuration is 1. Its atomic number is 1, its electronic configuration is also 1. Now here in this case, nitrogen, it has got 5 valence electrons, so we will draw 5. Okay, 1, 2, 3, 4, 5. Now around it place hydrogen atoms with their 1 valence electrons, 1 of this hydrogen, 1 of this, and 1 of this. This is the 1 valence electron of hydrogen which I have drawn here. Now nitrogen needs 3 more to attain the stable electronic configuration. So 5 of its own and 6 from this neighboring hydrogen, 7 from this neighboring hydrogen, and 8 from this neighboring hydrogen. So in this way nitrogen is attaining its stable electronic configuration. Hydrogen will also do the same. It will take 1 electron of the nitrogen. This hydrogen will also take 1 of the nitrogen. This hydrogen atom will also take 1 from the nitrogen. So again we are seeing the formation of single covalent bond, that is only 1 pair of electron is shared among the atoms. So it can also be written as N single bond H, single bond H, single bond H. Right. So these are few examples of the single covalent compounds. I'll show you more examples of the single covalent compounds. Now here, this one we have already understood. Let us do with the CH4. It has got carbon and hydrogen. So carbon atomic number is 6, so its electronic configuration is 2, 4. Hydrogen, you know, it is 1. So there are 4 valence electrons of the carbon. We will draw 1, 2, 3, 4. hydrogen, 1 valence electron. So you can write 1 here. There are 4 hydrogen, so you will have to place 4 hydrogen around it. Okay, so this is the valence electron of the hydrogen. Now carbon will attain its stable electronic configuration by taking 1 valence electron of these 4 hydrogen atoms. So now it is having 8 with it, so it is now having its 8 electronic configuration in the last shell. For this hydrogen, it is also taking 1 from the carbon. This will also take 1 from the carbon. This will also take 1 from the carbon, and this will also take 1 from the carbon. So again there is a single pair of electron which is shared, and therefore we write it as single bond H, single bond H, single bond H, single bond H, and this is popularly called as methane. So again we are seeing here that a single bond is there, that is only a single pair of electron is shared among the atoms. If you see H2O, okay, now hydrogen and oxygen, electronic configuration and atomic number both are 1. You can write here oxygen, it is having its atomic number 8 and its electronic configuration is 2, 6. So it is in need of 2. So you can place oxygen in the center, hydrogen around it like this. Now draw the valence electron for the oxygen, 1, 2, 3, 4, 5 and 6. This hydrogen 1 valence electron, this hydrogen will take this from this side 1, this will take from this side 1. Now this oxygen will take 1 from here, 1 from this hydrogen, and it will complete its stable electronic configuration. So again we are seeing single bond formation is there. Okay, so here also we are seeing that single pair of electron is shared among the atoms. Okay, so I hope that single bond covalent compound formation you are now, or you have understood clearly. Now let us go to the double covalent bond compounds. Remember here in this case you will have to show that 2 pair of electrons are getting shared. Atomic number of oxygen is 8, so its electronic configuration is 2, 6. Now this is one oxygen atom, this is another oxygen atom. Draw the valency around it, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it needs 2 more. So this atom will take 2 pairs from the other oxygen atom. This will take from the other oxygen atom. Now 2 pairs, one pair is this, another pair is this. So there is a sharing of 2 pair of electrons. So double bond O. So this is double covalent bond compound. If you see in the case of the CO2, it has got 2 atoms, carbon and oxygen. Now carbon atomic number is 6, so it will be 2, 4. Oxygen, it will be 8, so it will be 2, 6. Now carbon and oxygen, they will form double bond among itself. Okay, so this is carbon 1, 2, 3, 4. It's 4 valence electron. Oxygen with its 6 valence electron, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now carbon will take 2 from this oxygen, 2 from this oxygen. 1, 2, 3, 4, 5, 6, 7 and 8. It has now got 8 electrons. This oxygen will take from carbon 2 from this side, another oxygen will take from this side. So again we are seeing that there is a sharing of 2 pair of electrons among the atoms. So it is again a double bond covalent compound. Now moving to C2H4, it has got C and H, C electronic configuration 2, 4, H atomic number 1, electronic configuration 1. Now there are 2 carbon and there are 4 hydrogen, 1, 2, 3, 4. Okay, and these are the 4 valencies of the carbon, 1, 2, 3, 4. 1, 2, 3, 4 for this carbon. For hydrogen 1, hydrogen 1, hydrogen 1, hydrogen 1. Now carbon wants 8, so 4 of its own, 1, 2, 3, 4, 5, 6 from these 2 neighboring and 2 from the neighboring carbon atom. Okay, similarly for this carbon, 1, 2, 3, 4 of its own, 2 from its neighboring carbon atom, 5, 6 and 2 from its neighboring hydrogen atom. So among the carbon atom there is a double bond formation here, and between the hydrogen atom single pair. So this is an example of single as well as double bond. Between the carbon there is a sharing of 2 pair of electrons, so double bond, but among carbon and hydrogen single pair of electron is shared. So this is an example of double as well as single bond covalent compound. Now let us go to the next one, the triple bond compounds. Now in the triple bond compounds there will be 3 pair of electron which will be shared among the atoms. This is nitrogen, its atomic number is 7, electronic configuration will be 2, 5. So each nitrogen atom wants 3. This is one nitrogen atom, this is another nitrogen atom. You will be drawing the valence electron around it, 5, 1, 2, 3, 4, 5. For this nitrogen, 1, 2, 3, 4, 5. Okay, so 5 of this nitrogen and 3 from the neighboring nitrogen, 8. Similarly, this nitrogen, 5 of its own, 3 from its neighboring nitrogen atom. So in this way it will share 3 pair of electron, 1 pair, second pair, third pair. So nitrogen is having, in the nitrogen molecule there is a triple covalent bond compound it is. Now here also there are carbon and hydrogen atoms. Carbon, you know, atomic number 6, electronic configuration 2, 4, hydrogen 1. So its electronic configuration is 1. Now one carbon atom, another carbon atom. Okay, 2 hydrogen atom, 1, 2, you can write here. Now valence electron of carbon is 4, 1, 2, 3, 4. For this one, 1, 2, 3, 4. Hydrogen, 1 of its own, each of them. Now carbon wants to complete its octet, 1, 2, 3, 4 of its own, 5 it will take from the neighboring hydrogen and 3 from the neighboring carbon atom. So now this carbon is having 8 electron. Similarly, this carbon will do, it will take from its neighboring carbon and hydrogen atom. So there will be 3 pair of electrons between the carbon atoms, but hydrogen will take 1 from this carbon, this hydrogen will take from this carbon. So between carbon and hydrogen there will be a formation of single bond. So it can be written as carbon, carbon triple bond, carbon hydrogen single bond. So this is an example of single and triple bond. With this I will end this session. Hopefully you will be able to understand the different types of the covalent bonds and how we are drawing these structures around it. So let us meet in the next session to understand more about the carbon and its compound. And if you are liking my channel, then please subscribe to it. Thank you. Have a nice day.